Hello students, this is Sama Khan. Today I am taking a topic from Unit 4. That is Introduction to A to D and D to A converters and their types. This subject belongs to Computer Science Engineering. The subject name is Digital System and the subject code is CS304. So in this presentation we will learn what are the different types of uh, converters, that is analog converters and digital converters. So this is the introduction to A to D and D to A converters. An analog to digital converter, also known as ADC, is a digital circuit used to convert analog signals into digital format. The conversion of analog signal into digital format is crucial for their processing with the help of digital systems like microprocessors, microcontrollers, digital signal processors, etc. Therefore, ADCs, that is analog to digital converters, are important components in several digital systems like computers and other digital devices. An analog to digital converter is a digital circuit designed to perform conversion of analog signal into digital data format. It is also known as ADC. Analog to digital converters are essential components in digital systems like computers, data processors, digital communication systems, etc. The following figure depicts the block diagram of an analog to digital converter. We are able to see that here is the block in the center named as ADC, which is getting the input analog signal and getting the output digital signal. So this block diagram belongs to ADC. If the process is reverse, then we call it is a digital to analog converter. From this figure, it is clear that the input to an analog to digital converter is an analog or natural signal and the output is a digital or discrete time signal. In practical system, the analog to digital converter serves as an interface between internal environment and a digital system. Working of analog to digital converter. The working of an analog to digital converter involves the process explained below. The very first step is inputting analog signal. An analog to digital converter takes an analog signal as input. The analog signal could be a voltage, current, temperature, pressure, or any other physical quantity that changes continuously with time. The next step is sampling. At this stage, the analog to digital converter samples the input analog signal at regular interval of time. These time intervals are defined in terms of sampling rate. In the sampling process, the analog signal that varies continuously over time is measured at discrete instant of time to collect discrete values of the signal. The third step is quantization. Quantization is a process of assigning a digital or discrete value to each sampled value of the analog signal. In the process of quantization, the range of all possible analog values is divided into finite number of discrete digital values. Then we'll do the coding and that method is called as encoding. Encoding is a process of converting the quantized digital values into their equivalent binary numbers. These encoded binary numbers represents the sampled analog values in the digital format. The resolution, accuracy and precision of the analog to digital converter is determined by the number of bits used for encoding. And the next step is outputting digital signal, that is the output. At the end, the analog to digital converter produces a digital signal as output. This output digital signal can be processed, stored or transmitted by digital system. Performance. Now next we have the performance factor of digital to analog converter, and the performance of an analog to digital converter can be evaluated using several different factors. The following are the two most important factors: is the signal to noise ratio, SNR ratio. The signal to noise ratio of an analog to digital converter is defined as the measure of ability of the converter to differentiate between the desired signals and unwanted noise signal. Mathematically, the SNR of an analog to digital converter is expressed as the ratio of the power of the electrical signal that represents the useful information to the power of the noise signal that represents the unwanted disturbance. In practice, the SNR is expressed in decibels, that is dB, and the formula for calculating the SNR of an ADC is given below. SNR of ADC is equals to 10 log electrical signal power noise signal power, ratio of electrical signal power to the noise signal power. From this expression, it is clear that a high SNR represents better performance of the analog to digital converter. In other words, an analog to digital converter having a high SNR distinguishes the electrical signal from the noise signal more clearly. Therefore, it is defined desirable that the analog to digital converter have a high SNR so that it can accurately capture and digitalize smaller analog signal even in the presence of noise signal. So SNR is the ratio of 10 log electrical signal power to the noise signal power. Then the second important factor is the bandwidth of the analog to digital converter. The bandwidth of an analog to digital converter is nothing but the range of frequencies that it can sample and digitize accurately. The sampling rate of the analog to digital converter determines its bandwidth, where the sampling rate is defined as the number of samples of the analog signal taken per second. According to the Nyquist-Shannon sampling theorem, the maximum sampling rate of an analog to digital converter should be at least double of the maximum frequency component present in the input analog signal. It is an important factor to avoid misidentification of the signal that can introduce distortion or error in sampling. Let us take an example to understand this. Consider an analog to digital converter having a maximum sampling rate of 150 kHz, then its bandwidth should be limited to frequency less than 75 kHz to prevent distortion. As it is important that the analog to digital converter should have a sufficient bandwidth to capture the high frequency analog signal accurately. Here we have some different types of analog to digital converters. In digital electronics, different types of analog to digital converters are designed to fulfill the requirement of different application. Some of common types of analog to digital converter includes the following: flash ADC, semi-flash ADC, successive approximation register ADC, sigma delta ADC, pipeline ADC. Flash ADC, also known as direct ADC, is the fastest ADC available. This type of ADC has sampling rate of the order of the gigahertz. The flash ADC offers such high speed because they use a bank of comparators that can operate in parallel, each for a certain voltage range. The second one is the semi-flash ADC. The semi-flash ADC is a type of analog to digital converter that combines the fast speed of a flash ADC with a reduced number of comparator. These two features together make the semi-flash ADC compact in size and cost effective as compared to flash ADC. I think I have uh, written semi flash ADC twice, so just omit that. Now the next is sigma delta ADC. The sigma delta analog to digital converter, also represents as ADC, is a type of analog to digital converter that provides a high resolution and is used in application that requires precise measurement and signal processing, like in audio recording, high quality audio system, sensor based system, precise instruments, etc. Now the next is pipelined ADC. The pipelined analog to digital converter is a type of ADC which is similar to the SAR ADC, but it performs a coarse and refined conversion. It provides a balance uh, between resolution and the speed that make it suitable to use in communication system, medical test equipments, multimedia, industrial control system, etc. Now here are the some application of analog to digital converter. Analog to digital converters are used in various industries and fields where analog signals have to be processed, analyzed, or transmitted using digital system like computers. Some common application of analog to digital converters are listed below. In the very first is in the field of digital signal processing, ADC are used for converting analog signals obtained from sensors, microphones, or other analog devices into digital format for processing them using digital processor. Analog ADCs are also useful in audio processing application. ADCs are used to convert analog audio signal into digital format for storage, manipulation, and transmission in digital system. ADCs are essential components in various data acquisition systems used in the field of scientific research, industrial automation, and instrumentation. They are very useful in communication system. ADCs are used to convert analog audio or video signal into digital format for transmission over communication channels. ADCs are used in radio receivers for digitization of received radio frequency signals. ADCs play an important role in several medical equipment, healthcare systems for converting various analog biosignal and physiological parameters like heart rate, blood pressure, oxygen saturation, EEG signal, etc. into digital format to process them using digital system. So student, this is all for this presentation. Thank you students. Thank you so much.